Hello, today I'm gonna solve number 101 symmetric tree. Okay, let's see the problem. Given a binary tree, check whether it is a mirror of itself, which is symmetric around its center. For example, this binary tree 1, 2, 2, 3, 4, 4, 3 is symmetric. But the following 1, 2, 2, no, 3, no, 3 is not symmetric. Okay, we have to check the binary tree by searching its tree node and compare its values or its structure to know whether it's symmetric or not. Okay, how to solve this problem? There's a note that bonus points is given if you could solve it both recursively and iteratively. So we're gonna think about the two solutions. Okay, this is the function we have to fill to return true or false for its symmetric characteristics. At first I thought about the in-order traverse, which is the algorithm traversing the left child first and then root value and the right child sequentially. So when I checked the simple symmetric tree, its in-order traverse sequence was also symmetric. But as you can see, the in-order traverse sequence is symmetric. -1 value is representing the null pointer. So I realized that in-order traverse algorithm is not appropriate to solve this problem. So we should find a way to directly compare the symmetric nodes from root to the bottom. We could use the recursive function over the iterative way. If you see the right diagram, it shows that three nodes we should compare to know it's symmetric or not. As you can see, the left child and the right child should be compared for its values. And then we can go down to compare the left child and the right child in the next level. And also compare the right child and the left child. We could know that this pattern is repeated in the next child nodes. Okay, let's see the solution. This is the code provided in the liquid.com. Let's see the mirror function. Its mirror function has two parameters, t1 and t2. As you can see in the diagram, we should traverse the two compare nodes at the same time. That's why its mirror function has t1 and t2 as its parameters. t1 and t2 are both null values. It's symmetric. Only one of them are null pointer which should return false. It's not symmetric. In this case, both t1 and t2 have valid pointers, so we have to compare its value. And also we have to call its mirror function recursively for its left child and right child, and also for its right child and t2's left child. As you expected, t1's left and t2's right are a symmetric relationship. And also the t1's right and t2's left child are symmetric each other. So we call its mirror function recursively, moving to the bottom of the tree. Okay, this code performs 4 milliseconds, which is faster than 85.21%. Okay, let's see the second solution, which is the iterative implementation using queue operation. This solution just pushes the left child and the right child, having the symmetric relationship, and then pop the two tree nodes at the same time to compare its values. First, check its pointers are valid. This is the same operation used in the recursive solution, which I have explained just before. And then compare its values to return false if the two values are not same. And then push its children in next level. At this point, we should focus on the first pair and the second pair. T1's left and T2's right child are symmetric relationship. And also T1's right and T2's left is symmetric. In this while loop, compare operation is performed for pair nodes. So push operation should be done for its symmetric pair nodes. That's the key of this solution. This code performs 0 millisecond, but logically this solution has the same time complexity as the recursive solution, which is O(n) time complexity. Okay, thank you for watching. See you next time. Bye bye.